Today we will deal with solutions and colligative properties. Solutions and colligative properties. What are the main topics to be discussed under this chapter? The main colligative properties. So basically this chapter can be divided into two parts. One part is concentration terms, other part is colligative properties. What are the concentration terms? What is the usefulness of the concentration term? So concentration terms are used to know the relative quantities of the solute and solvent present in the solution. What are the major concentration terms? Weight by volume percentage, weight by weight percentage, molarity, normality, mole fraction. These are the concentration terms. And what are the colligative properties? What do you mean by colligative properties? The properties which depend upon the number of the particles are called colligative properties. What are the colligative properties we have under our syllabus? RLVP, relative lowering of vapor pressure, which is related to the Raoult's law of vapor pressure. Next, elevation of the boiling point, and depression in the freezing point, and osmotic pressure. These are the topics which we have to discuss today. Now we shall give more emphasis on the colligative properties today. Why we are giving more emphasis to the colligative properties today? Because these concentration terms, discussion about these concentration terms will be mixed with the colligative properties. After all, colligative properties are based on the concentration terms only. What are the concentration terms that are useful in the calculation of the RLVP? Molality and mole fraction. And for the calculation of the elevation in a boiling point and depression in the freezing point, what is the major concentration term? We are using molality. And regarding the osmotic pressure, we use molarity. So discussion about the concentration terms will also be carried along with these colligative properties. Now, in discussing the colligative properties, what is the first? RLVP, relative lowering of vapor pressure. So RLVP is equal to RLVP at a given temperature. RLVP will be equal to X1. What is meant by X1? Mole fraction of the solute. Next, elevation in the boiling point. Elevation in the I into X1. Elevation in the boiling point is given by the expression I into Kb into m, and depression in the freezing point is given by the expression I into Kf into m. Osmotic pressure is calculated by using the relation. Osmotic pressure is represented by pi is equal to ICRT. What is meant by I? Van Hoff's factor. So the value of Van Hoff's factor becomes significant only in case of the electrolytes. For non-electrolytes, Van Hoff's factor will be equal to 1. Now we will discuss what is meant by Van Hoff's factor and what is the relation between the Van Hoff's factor and the degree of dissociation. Suppose in case if the electrolyte undergoes dissociation, the electrolyte undergoes dissociation, the electrolyte undergoes dissociation, alpha is equal to I minus 1 by n minus 1. What is alpha? Degree of dissociation. What is I? Van Hoff's factor. What is n? Number of particles formed due to the dissociation of 1 mole of the electrolyte. In case of the association, alpha value will be equal to I minus 1 by n minus 1. 1 by n minus 1. If the electrolyte undergoes association, then this is the way, this is the relation between alpha value and I value. So basically by definition, what is I value? What is I value? Final number of the particles, final number of the particles by initial number of the particles, final number of the particles by initial number of the particles, or experimentally observed colligative property, by theoretical colligative property, because colligative property always depends upon the number of the particles, or in case of the molecular weight, theoretical molecular weight by observed molecular weight, because colligative property is inversely proportional to the molecular weight. So this is briefly about our discussion. Now we will go ahead.